So welcome everyone to today's video, semiconductor in photovoltaic cell. So introduction. When light reaches a solar panel or photovoltaic cell, it can be either reflected, absorbed or passed right through it. At the heart of a solar cell is a semiconductor layer which is unequivocally the most important parts of the cell. So just what this introduction means is how the semiconductors are working in the solar panels that provides electricity and many other things. So we are going to see about that. So about the semiconductor, it is a substance that has specific electrical properties that is enabled to serve as a foundation for computers or other electronic devices. So it is a solid chemical compound that conducts electricity under certain conditions but not others. So this is a semiconductor, and the sunlight falls on the semiconductor, the solar panel. So this is the basic. When the light shines on the photovoltaic cell, what is photovoltaic cell is nothing but it is a type of cell that is used to absorb the heat from the sun and transmits to the semiconductor to convert it as a electricity. The semi means that it can conduct electricity better than insulator but not as well as good conductor like a metal. So there are several semiconductors material used in PV cells, and when the semiconductor is exposed to light, it absorbs the light energy and transfers it to negatively charged particles in the material called electrons. So that's how the basically the solar panel works with the help of semiconductor. So this is how the connection goes. I'm sorry for the blur. So this is a PV inverter and meter, grid, and everything goes for appliances. I'll give you 2 minutes to read this. So, or you can pause and read this. This is basically a detailed explanation of what is solar cell and photovoltaic, how it is converted and everything. Power semiconductors used in solar power. The market for semiconductor used in photovoltaic inverters which convert direct current to alternating current from PV modules will continue to expand in long term. One of the most important trends in semiconductor industry today is the development of solutions that improve energy efficiency. In particular, semiconductors play a key role in PV inverters where major power savings can be accomplished. The function of semiconductors in solar cells. So this is basically about how the semiconductor works in the solar cell. And commonly used semiconductor materials in solar cells. So there are a few types of materials that can be used as semiconductor in the solar cells. One of the type is silicon and other is copper, indium, gallium, dislike, and CDTE are the most common thin film PV semiconductors that is used to manufacture thin film solar cells. They possess high efficiencies and suitable properties as PV semiconductor materials. However, the manufacturing of these materials by combining 4 elements is extremely challenging. So others can be used as like perovskite semiconductors. They can be assembled easily and realize efficiency similar to CSI. CSI is nothing but silicon. Moreover, the semiconductor can be used in combination with other semiconductors such as to optimize multi-junction solar cell performance. However, quantum dot semiconductor materials are not efficient in converting light energy to electrical current. And this is the inside of a photovoltaic cell. So the sun's energy from the light goes on the glass, and the transparent negative terminal, and this is what the red color is positive terminal, and below the glass there is n-type layer in the semiconductor, and the dotted line is junction, and uh, below the junction is p-type semiconductor, and these are connected from the wire and which goes to the terminal here, and the flow of electrons makes the current. So these are all done by the band gap between the valence band and the conduction band from the electron energy. So that's all. Thank you for watching this video, and I will see you again with the another video.